Dynamic characteristics of a measuring instrument: speed of response and response time, dynamic error, fidelity, measurement lag, dead zone. From the above, speed of response and fidelity are desirable in a dynamic system, while measurement lag and dynamic error are undesirable. The output reading of an instrument versus time. Actually, measuring quantity is like this, but the indicating instrument readings are like this. Speed of response. It is defined as the rapidity with which an instrument or measurement system responds to change in measured quantity. Response time. The time required for instrument or a system to settle to its final steady position after the application of input. Next, measurement lag. The delay in the response of an instrument to a change in the measured quantity is known as measuring lag. This lag is quite small, but this small lag becomes highly important when high-speed measurements are required. In the high-speed measurement systems, as in dynamic measurement, it becomes essential that the lag be reduced to minimum. Measuring lag is of two types: retardation type and time delay type. Retardation type. In this type of measuring lag, the response begins immediately after a change in measured quantity has occurred. Time delay type. In this type of measuring lag, the response of the measurement system begins after a dead zone after application of the input value. Next, the important term, fidelity in dynamic characteristic. Fidelity of a system is defined as the ability of the system to reproduce the output in the same form as input. It is the degree to which a measurement system indicates changes in the measured quantity without any dynamic error. If linearly varying quantity is applied to a system, the output is also linearly varying quantity. The system is said to be 100% fidelity. Ideally, a system should have 100% fidelity and the output should appear in the same form as that of the input, and there is no distortion produced in the signal by the system. In definition of fidelity, any time lag or phase difference between output and input is not included. Dynamic error. It is defined as the difference between the true value of quantity changing with time and the value indicated by the instrument if no static error is assumed. However, the total dynamic error of the instrument is the combination of fidelity and the time lag or phase difference between the input and output of the system. Dead zone. Dead zone is defined as the largest change of input quantity for which there is no output of the system. Dead time. Time required by an instrument to begin to respond to the change in measured